Alright, should be a DraftPhysics.com video presentation on the new used computer. Yeah, so that was pretty good, right? Complete crisis, computer blows up, and it's fixed for $100, so that's okay. Anyway, back to normal anyway. Had to do a little configuring, but it's pretty close to what it was before, except a little faster now. So it might even be better. The frame rate might even be better. Anyway, so that's good. What's bad is, Pyrrho's made a video totally unresponsive to anything I'm talking about, anything I'm illustrating, any points I'm making. So it's just so useless. So the whole video starts, 3/4 of the video, and then the last quarter is, about his boat. So, so there's really nothing to respond to in the video. As I've shown, this is the actual experiment that is the outcome of his formula. So the whole formula he's describing creates this paradox that I've now shown 4 times at least. And we'll show it again, right? And so here's where he's deriving the formula. That's irritating. Freaking professors who have to steal money. Alright, so that's the end product of doing your combining 2 formulas. And the 2 formulas, understand, they're both saying the same thing, right? That energy is conserved. Momentum saying it's conserved, kinetic energy saying it's conserved in elastic collisions. But the funny part is that it's 1/2 mv squared, right? So it's the same components. Mv are the only variables are m and v. So you have 2 formulas with exactly the same variables. So just understand how silly in a way this is. To say I've created 2 formulas that are going to help me solve for the unknowns, when the 2 formulas are exactly made of exactly the same elements. How can they provide you any unknowns when they're exactly the same elements? But anyway, we'll just forget that part. So this is exactly what he shows, okay? And the first 3/4 of his video is just doing this stupid mathematical equation that I already called the Frankenstein, because one of these can't be right. Either momentum's garbage or kinetic energy is garbage. They both can't be right because they're both definitions of a real pressure or a real energy in the universe. A Newton is the stick of butter, the weight of a stick of butter. A joule is a stick of butter falling a meter. It's a pressure. It's momentum. Okay, and if you want to call it kinetic energy, fine, you can call it whatever you want, but the fact is, it's exactly the same thing. It's a weight. When the butter hits the ground, it has a weight, a pressure. That's the joule, okay? That's what the energy is in the form of. And it can be completely understood of that's its momentum, its mass, and its velocity, or what makes it go squish when it hits the ground. It's what makes this hand clap happen, is mass and velocity. It's the same thing they're describing. Okay, so he doesn't answer, he doesn't respond to that at all. There's no theory here. There's just math, no theory, no model, no explanation of how the energy is stored, how it's transferred, nothing. They have no model of any of it. They just do this stupid mathematical equation, again, that isn't saying anything. It's nonsense. And so there, we've solved the problem. Okay, and then I explain this. Okay, so Professor Lewin does this little gimmick experiment, and it's just a gimmick because they're using the word elastic to describe 2 things: a ping pong ball and a steel ball. They would say these are both elastic objects, when clearly one of them is really a spring. One of them is a spring. The ping pong ball is a spring. It's not a steel ball. It's a spring. It stores energy and then releases energy.
Ratio is not infinity to 1, but is 500 to 1, which is quite large. And so what I will first do is very intuitive. I will first bounce the ping pong ball off the bowling ball, the billiard ball. The ping pong ball comes back almost with the same speed, not quite, because the ratio is not infinity to 1, but it is 500 to 1, and the billiard ball will do practically nothing. That's exactly what you see there in case 2. There we go. You see the ping pong.
So everything's sort of normal, right? We lost a little bit. The ping pong ball didn't come all the way back. The billiard ball did actually move, so it took some of the energy, no doubt about it, and some of the momentum of the ping pong ball was lost, and the ping pong ball sprang back off the 8 ball. But we know it sprang back off. It didn't kinetic I mean, it didn't elastically, like if it was a steel ball, could he do the same experiment? That would be the question. And my statement would be, it ain't going to work because it can't make a steel ball that light. Okay. Hard to make a hard object that light. So we'd have to make it out of some kind of foam or something. And will the result be this dramatic? No chance. So the formula won't work. So this is just the point. They just create experiments that do work, but they have gimmicks in them. And here the gimmick is clearly ping pong ball. So let's go to the next experiment he does.
The speed of the billiard ball. And of course, you cannot see that quantitatively because we don't do a quantitative measurement.
Yes, because we don't bother doing physics experiments and finding out whether these formulas actually work by doing something quantitative, right? They don't want to find out, yeah, it's pretty far off actually.
Of the speed of the ping pong ball. But you will see that it bounces up quite high. So there we go. The billiard ball onto the ping pong ball. Look at the billiard ball alone, forget the ping pong ball, and try to see that the speed of the billiard ball...
Well, try to see, the fact is the ping pong ball bounced twice as far. That's because it not only is getting the velocity of the ball, the heavy one moving, so that's all it can do. The heavy ball can only give it its velocity. It can only go 30 miles an hour. It can only push something 30 miles an hour. It can't push anything 60 miles an hour. So it can't make the ping pong ball or the other ball leave, okay, with twice the velocity. Can't do it. It can only give it the velocity it has. And the trick is, if you use a ping pong ball or a tennis ball or some ball that has compression and therefore is a spring, then that can compress and expand, and that will add to the velocity. So that will be the place where it gains the extra 30 miles an hour in this example I just used. So if it was 30 for the billiard ball, the compression of the ping pong ball is another thing the billiard ball can do. It can compress the ping pong ball. It has plenty of energy because it's so much bigger, has so much more mass, lots of energy left over. And so when it hits the ping pong ball, no problem denting it, and then it gets the ping pong ball going 30 miles an hour, and then the ping pong ball undents and goes another 30 and leaves with 60 miles an hour. Now it's less than 60 miles an hour because we know it wouldn't go twice as high in gravity if it was going twice the speed. So it's only going 1.5 the speed or some other fraction.
It's practically unaffected by the collision. That's what you see there. V1 prime is V1. You see it's practically unaffected. Now, of course, it is way harder to see that the ping pong ball gets twice the speed of the billiard ball because we don't do...
Yeah, well, it's obviously not twice because it's not 4 times as high, exactly. But the point is that it's getting twice the speed is the prediction of the formula. So the formula is actually predicting twice the speed. So the billiard ball is going 30, the ping pong ball leaves at 60. And as I state, and I don't think it's a refutable explanation, the only reason why that's happening is because you're using an elastic object that's truly elastic in the sense that it's a frickin' storage device. You put energy into it, it compresses, and then it expands and releases that energy. And that's the only way this would work. All right, so we'll move on to the other experiment, the paradox, the clear paradox, the overwhelmingly obvious paradox. All right, that Pyrrho hasn't responded to or won't respond to. So this is the consequence of exactly the equation Pyrrho wastes my time anyway, in my opinion, just wastes my time showing me an equation I already saw, and I already found it to be lacking and wanting and stupid. I already have debunked your whole F equals ma thing. Newton said F equals momentum divided by any unit of time. The time can be seconds, minutes, hours, months, years. And it's just in units of seconds or units of minutes or units of anything. And so if I just make it the unit of time, I just make it the completion of the experiment, then it's basically F equals change in momentum. The force is momentum. If your momentum changed, the force did it. The force momentum became your momentum. That's how much force acted on you. how much change there was in your momentum. So the total change in your momentum over the total time that the change took place. That's a 1. So you put a 1 in the bottom of the fraction and you have F equals change in momentum. That derivative works just fine. All right, so this should be the right place. All right, so this is a paradox. They can play a game with their plus and minuses and say it's not some more energy. It's obviously more energy. What goes in is a certain amount of energy. What comes out is clearly more energy. So you have stuff going this way and you have extra stuff going that way. So you have both things. You have more energy. So obviously you had to hit something explosive. You had to hit something that added energy because your total energy is much higher at the end of the experiment. So you have a magic box. You don't put anything in. You don't put fuel in. You don't put anything into the magic box. You swing your object in with just a certain amount of momentum, and what comes out is more momentum. That's the fact.
There we go. This is the one that will have no speed, and this is the one...
Oh, wrong experiment. Sorry. So, yeah, these are just the two equal ones. So we already know the two equal ones work. It's this 3 thing that's the one. Okay, that's already got the numbers. All right, so here's his predictions, blah, blah, blah. No, that's already the answer there. Okay, so I got to go back. It's a very short experiment, quite obviously. All right, back here somewhere.
Is the car which has twice the mass. It's important that I zero it. And now this one is going to come back.
All right, now this is clearly a paradox if you don't believe in free energy. So I'm just saying, because clearly it can be used to create perpetual motion. It can be used to create energy that keeps increasing as you run it through a system. So if I take this experiment and just reduce it, keep replaying it with heavier and heavier objects, I'll create more and more momentum. And momentum is the same thing that asteroids have and that elephants have and dinosaurs have. And so I put in a little flea amount of energy and I get out at the end an elephant worth of momentum. And that's paradoxical, and I don't know how anybody can say that's not exactly what this experiment demonstrates, is a paradox. It demonstrates something that shouldn't be possible.
So you're going to see this one come in, give you the time here. This one goes through here, gives you the time here. This one will come back, gives you the time here.
Right. And we've already done this 4 times. I haven't gotten anything close to anything called a rational explanation of why this is okay.
ID 0. Okay. You ready? Yeah. There we go.
All right, so this is the initial thing. So this is your first thing goes in. All the bigger numbers mean slower speeds. Okay, so the bigger the number, the slower the speed. So this is what went in. The thing that went in sent something going back 1/3 the speed. So 1/3 the speed going in, and it bounces back with another third. So we have 1/3 going this way. And then we have 2/3 here, in the sense that this should be only half the number, so it should be 246, and it's only 186, so it went much faster than it's supposed to go. If it was half, the half massive object should move, the twice massive object should move half the speed. It's moving much faster than half the speed. So now I have 3/4 going this way. 3/4 of the speed that went this way is now going this way. And that can't happen, because it's a heavier object, twice as heavy. And if it's going that velocity, that's more energy. Okay, so the real answer here is kind of simple. He used springs. Now, I showed the part where he's saying I'm using a spring on here to make it elastic, when they're already steel, they're already aluminum. the little metal things. They're already supposed to be elastic. So why is he putting springs on them? They're already elastic, so they should work without springs. So he's making them something else. He's putting a storage device, a ping pong ball. He could have just put ping pong balls on them, right? And that would have done the trick. Because the trick is that the spring is going to store the energy and then release it without using any energy, because the spring's compression is going to be in exactly the same direction that the cart's moving. So it's not going to lose what it stores. And then it's going to push the other cart with the momentum it has still, because the spring basically absorbed the compression but still has the momentum. It's going to push the cart at half the speed, and then the spring is going to add the other third. The spring is going to add what makes it 2/3 instead of 1/2. The other third went the other way. So they'll say momentum was conserved because something went this way and this way, so you can just kill those two and pretend they didn't happen. But that would be like saying the sun's not producing any energy because it sends photons that way, and then it sends photons towards us, and therefore it doesn't have the energy. It doesn't exist. It doesn't have any momentum. The photons don't have any momentum because one went the other way. Well, they still have momentum in the direction they're traveling, and that's the important thing. So as an energy image, you gained energy. You went in with, say, 100 joules, you sent 30 this way, and you sent 130 that way. So 100 went in, you got 130 coming out this way, and you got 30 going that way. So if you looked at it as an energy equation, it's clearly free energy. All I have to do is you got a 2 kilograms, twice as heavy. So in this case, 400 grams. So I move it up to 800, and then I go 1600, and I just keep doubling the mass, keep letting the thing bang into, just go 1 kilogram, 2 kilograms, 4 kilograms, 8 kilograms. Just let it sequence through, and after 4 little interactions, I'll have doubled my energy, doubled my momentum. Now, it's a paradox. What's the explanation? Why is this rational? Why is this acceptable? And something besides a mathematical explanation would be really interesting. Something mechanical that explains why it's okay. It's okay to have that extra. See, you could understand it if you put gunpowder on the end of the thing, right? And then you smashed it into something else and the gunpowder exploded. Well, then you'd say, well, I put extra energy in because I put the gunpowder in there. I put a loaded piece of energy in there. But there's no gunpowder here. There's no extra fuel. I didn't put a little vial of gasoline. I didn't make something to make the 30 joules this way and the 30 joules that way. The 30 momentums, whatever you want to call it. I didn't make anything that did the extra. The spring did the extra. And I didn't have to compress it ahead of time. I didn't have to do any work to make the spring create the extra momentum. That's free energy. So that's what you have to respond to, Pyrrho. But he says he watches the videos. He doesn't watch the videos. He doesn't pay any attention to the videos. So this really is pointless. But just so the audience understood, I understood what he said clearly. Clearly I was aware of the formula. Clearly I've showed the video 4 times now. Clearly I'm quite aware of all that crap. I want an explanation for how this isn't free energy. How I couldn't do exactly what I just said. Just put another cart here, and another cart here, and another cart here. Just make them heavier and heavier and heavier. Obviously an air track's not going to work for that. You need some other frictionless device. But the point would be, is you're clearly going to keep increasing the momentum, which is essentially the weight or the pressure. And that's real energy because it can do real work. Twice the momentum, twice the work you're capable of doing. 3 times the momentum, 3 times the work. It's just the truth. Alright, so we'll leave it at that. So this will be proof of concept. The computer works. So I feel good about that. Oh, I could play a little bit of Pyrrho, but it's just no point. So this is after he showed the equation from Khan Academy, his preference, I suppose, for some dopey reason. I don't think Khan Academy is all that good, actually. Their two-slit analysis was complete fail. But anyway.
You have to add up and why you need both concepts. It's a very good article that certain people...
Okay, you don't need both concepts, blah, 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 blah. This is fail. It's free energy formula, blah, 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 blah.
I don't know, people in New England. People in, New England.
Yeah, whatever, this stupid game you're playing. Okay, yeah, we've known each other forever, whatever, blah, 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 blah. You shall be named nameless, okay? Him who, sits in pond water, okay? There, that'll be your new name if you want a new name.
Should read. It's very illuminating.
All right, so I don't need to read it. It was in part of Professor Lewin's videos. I played it, enough times now. Clearly not the subject. The formula isn't the subject. The physical experiment is the subject. And the consequences, what it means consequentially, is the subject.
So I think that does it until I can get my whiteboard working again, in which I...
Yes, we'll just make the video quite horrible. So he was going to do this on his whiteboard, which again, if you're just going to do math equations, I'm totally uninterested. I don't think that's responsive to any of these issues. I don't think it explains any of these phenomenon. I don't think it explains the physics at all. Unless you can draw a picture of a rocket and how 2,000 joules goes out one way and 4 joules goes out the other way, and somehow the rocket doesn't turn, not interested. I mean, I don't think it's the subject, frankly. The whole point of the argument is that your math is suspect, that you can't even get the beginning of Newton right, that you've already perverted and distorted what Newton said. I mean, you've basically put formulas in his mouth, just like you put crap in Einstein's mouth. And, so there's no point in starting there and arguing from that position. And especially when he does it in this context where he just says, well, that's why we need this two concepts. Well, for 150 years, you didn't have this formula, so you didn't need these two concepts. What for the 150 years that you people argued for this kinetic energy crapola was the reasoning? Oh, the reasoning was religion, frankly. And that's it. It was called a living force, and that wasn't just some sort of not significant silliness. That was really quite significant, because that's the type of people who wanted this to be true. People who would believe in something called a living force. People who would think it was good science to call something the living force. Leibniz believed in monads and solitons. And soliton meant soul, like religious soul, not solar. Okay? Anyway, but you're not responsive to any of these points, so what's the point? This is not a proper response video, in my opinion. Not even close.
And go through the 3 types of values and what they all mean. Mass by time, time by mass, distance by time, time by distance.
All quite irrelevant, because they're all gimmicks. Everything that moves forever. It doesn't go with distance unless you apply another force to stop it. So none of this time or distance shit means anything. It's all just nonsense. Something's either going fast or it's going slow. Something either is heavy or it's light. That's all there is. There's light things going fast, heavy things going slow. You say the light, fast things have more energy, but you don't have a single experiment in the history of mankind showing you collecting that extra energy.
Time by time even. Like a watch can be time by time. Like, what do you mean? Well, I have a watch and it loses 1 second a year. It's time by time. So you can have all of them, mass by time and time by distance. You can have mass by distance. How could you have mass by distance? Well, let's say you have a pole and it's got a certain mass for every distance length upon the pole. Right?
No. No, it's one object. You can't cut it into smaller objects. You have to cut it into smaller objects. Can't weigh different at different locations unless you break it into pieces.
All of these mixtures, mass by time, time by mass, distance by mass, whatever, they all have a meaning. Some of them more, useful in a day-by-day context. But they all have a meaning, and so do when you start taking, something like momentum that has mass, distance, and time in it, and adding another time, or another distance, or another mass.
Well, it doesn't have distance in it, so again, this is just more nonsense. It's clearly just a very simple thing. It's your mass and your velocity, and essentially what it creates is weight. When you weigh yourself on a scale, do you disagree that you're weighing your momentum? Gravity's gave you momentum. It's your momentum that's showing up on the scale. And if I drop you before you hit the scale, you'll weigh more. Do you understand that as a concept? Because it's exactly how the joule is defined. It's exactly the same concept. The Newton is the stick of butter's momentum. That's a Newton. An apple's momentum in gravity. Take it out of gravity, then there's no momentum. You're measuring the momentum. A Newton is 1 unit of momentum. Okay, I drop the unit, 1 meter, and the impact, the weight, is now a joule. Those are the definitions of your units. So how can you separate momentum from energy? How can you separate weight from energy? Because that's really all it ever is weight.
Divided or multiplied. Because division and multiplication both have physical meanings when you're doing them with these 3 physical.
They only have meanings to geometry, so there's always algebra behind the numbers.
Values or quantities. Now, it's worth pointing out that most car wrecks, most car collisions, are really not very elastic. But you can still...
So, see, the word elastic just doesn't mean anything. All it means, as I've stated, is whether or not the energy keeps going in the direction you hit. If it stops going, on the linear line of your initial motion and it starts going sideways in any way, tangential, if it starts moving tangentially, then the energy is really hard to calculate because it's going in all these tangents, okay? You can't just collect it by ringing a bell somewhere. You have to put a bell all over the place and collect all those different vectors. So that's the only difference between elastic and inelastic. Is an inelastic collision means you have lots of little pieces flying in all kinds of numerous directions. And in an elastic collision, the energy stays on a linear plane, in a dimension. That's it. That's the difference. And so it's still just transferring your energy. You can transfer it in the direction you're moving, or you can transfer it in some other direction. If you transfer it in some other direction, you might not see it. So a car accident just changes, laser energy, laser beam type energy moving in one linear line, and it changes it into energy moving in all kinds of lines. It scatters the momentum. Same momentum, just scatters. So whether it's elastic or inelastic doesn't change how many little particles of mass are going to be moving a total velocity. The total mass and the total velocity can't change in the universe, ever.
Do physics on inelastic collisions. I think that's been shown as well.
So none of it's been shown, so this is just more blah, 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 blah. There are no experiments collecting kinetic energy.
It is worth noting that, unlike billiard balls, auto accidents, not so elastic. And if they were elastic, it wouldn't be that great because, the jerk and...
whatever. Obviously, we're, okay, not inelastic. We're not elastic. So we're like clay. We send the energy in all kinds of directions and ain't good. It turns us into jello mush. But anyway, I think that's all he says. So
acceleration and elastic collision of changing direction almost instantly is, that's a great one.
So almost instantly, blah, blah, blah. Obviously, it doesn't really happen almost instantly. It happens at the speed of sound in whatever the material is. So... depending on how, like a ping pong ball, you're back to the speed of how much the air pressure moves, so you're back to a pretty slow speed.
Human body. J. Troy Doe, I'm kind of talking to you. All right. Cheers to everybody. And may you all have a wonderful weekend like I had. I just got...
Whatever. Okay, so he talks about his boat, blah, 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 blah. So anyway, enough of a video. So, a response video should respond to the points made in the video. And I don't really care. Somebody doesn't have to play the whole video I just made. They could just go to the key points where I'm making these key points about paradox and how you're putting words in Newton's mouth, and how all of this formulation stuff doesn't have anything to do with the mechanical universe. Frankly, it's all suspect. It's quite suspect. So, and then I'd ask the simple questions. Quite obviously, Professor Lewin should be able to demonstrate elastic collisions with aluminum objects without adding springs to them. So why the springs? And obviously the ping pong ball is clearly a storage device. Clearly. All right, anyway. So that we'll call enough of a video. So I'm pleased to be back to normalish and such. So this has been a DraftScience and Physics.com video presentation. Thanks for pretty much just ignoring it. Appreciate it. Not really. I really don't appreciate it, but stuck with the audience we have, actually. Don't know what else to do about it. Offered money, done this, done that, emails, blah, blah, blah. Just can't scrape up an intelligent counter argument anywhere. Just quite pitiful. But I don't have a very high opinion of the human race, but it just keeps getting lower and lower, frankly. Just lower and lower. Yeesh. Okay. Till next time.